Here's my pre-calc. That's what we did today in class. Horizontal and vertical asymptotes. I'm smiling because how important is that lesson for AP Calculus? Vertical asymptotes, maybe not so much. But the ha is the same thing as what, guys? The infinite limit, right? As x goes to infinity. That's exactly right. So that's my pre-calc. So a year ago today, that's what you guys were putting up with. Okay, so here we go. Chapter 3 is pretty long, right? So if they're saying 18 lessons, 18 hours, 17 hours, you know, we're already here. Increasing and decreasing, and the first during the test. What does it mean to increase? Okay, this little 3-5 here is important, guys. If f prime is greater than 0, what does that mean? The slope, what does it mean for a slope to be greater than 0? It goes what directions? Two of them. Up and right, but if we went backwards, it'd be what? So would you guys agree that from here upwards is a slope positive? Now, it changes, but it's still positive slopes, right? What happens if f prime is less than 0? If f prime is negative, what's a negative slope? Downward, down and left, decreasing, right? So would you guys agree that from here to here, are you always having a negative slope? What's true if y prime equals 0? Isn't that definition of a critical number, right? If it equals 0 or undefined, all right? So make sure you guys can remember what that says here. This is all common sense, not much to talk about, okay? What I do want to talk about involves the next page. Does this look familiar to anybody? What's that called? Yeah, difference quotient. That's slope of the tangent line. That's mean value theorem. That's everything that we talked about. Slope of the secant line, slope of the tangent line. All right, so what I want you guys to be prepared for is the following statement here. Find the intervals on which this thing is increasing or decreasing, okay? Now, one way of doing this is to take a look at the picture of the graph. But that was so pre-calc of you. Remember I asked you before, last year, find the intervals, and what were you supposed to do? Find your max and min. Was there a cool little feature in your calculator? Left bound, right bound, think your favorite number. You might not have that ability on the non-calculator part of the test. But by looking at, you see how it increases, then it decreases, then it increases, okay? So what we're gonna do is the following. What is it? X cubed minus 3/2 x squared. I guess I should turn this on first. And then let's take a look here, okay? All right. Relative exponent. Occur when f prime equals 0 or undefined. And you need to do what are called sign charts. And you do have experience doing sign charts from pre-calc. My lesson with my pre-calc students Monday will be what I'm going to tell you next Monday and say, well, I guess you have a quiz. You'll see what I mean. I think the equation was it x cubed, I think? Minus 3/2 or something? Or I don't want you guys to see the answer. Yeah, minus 3/2 x squared. Okay, x squared minus 3/2 x squared. What are the intervals for ints, for increasing or decreasing, okay? Am I giving you a region from 0 to 4? No. So are we doing absolute extrema? Remember, the extreme value theorem only works as long as it's going from A to B, right? Now, guys, this is a polynomial, right? I mean, it's a little fraction here, but is this thing going to always go somewhere? How does a typical x cubed look like? By the way, leading coefficient test, if x cubed is odd and the number here is positive, how does a positive odd cubic thing look like? Most likely it looks like this, right? Remember left end, right end. You guys are doing down, down, up, up. How important are these concepts for calculus? Albert, stay awake. Hi. Okay, so remember, your critical numbers will work. So therefore, when does f prime equal 0? Obviously not undefined. When, okay, what's the derivative then? 3x squared minus, okay, what's 3/2 times 2? Huh? Okay. When does that equal 0? When 3x parentheses
0
x minus 3 equals 0. So our two critical numbers are 0 and 3.
It's x minus 1.
X squared?
No, it's
What did I do?
3x times x minus 1.
Okay, 3x x minus 1. Okay. I thought something was 1 over. This is a lot like you did for 3.1, right? You found your critical numbers. Then what do? We did a little chart. We also had endpoints, and we plugged them in, right? Highest was your max, lowest was your min. Not anymore. What I want you guys to do is this following sign chart. When x is less than 0, well, that's like saying negative infinity, right? When x is 0, when x is 1, and when x is greater than 1, would that be a thing for infinity? Okay? Now, think about what numbers are between 0 and negative infinity. Negative 1. You guys were doing sign charts before.
Yeah.
What's a good number between here? And then hopefully you say 2 or 20 or who cares about. Now, we're not plugging these into the original function. This is not absolute extrema. This is called relative extrema. Remember, we only find our intervals of relativity based on if the first derivative is what? Positive, negative, or 0, right? So when you plug in -1, you're actually going to plug in -1 into what? The derivative. When you plug in 1/2, you're going to plug in 1/2 in the derivative. F prime of 2, not f of 2. Are we clear? Now, there's two options. There's usually an easier one. Like, is this one option right here? Is this the first derivative? Is this also the first derivative? So for me, I think it's easier to use this one right here. Because guys, what's positive times positive? What's positive times negative? Do I care what number value I get here? I only care about the sign. Is it a negative or is it positive? Okay? So here we go. When x is -1, this is negative, and this is -1 minus 1. So the product of negative and negative makes. So guess what? You're going to take your pencil and hopefully just put a plus sign here. When x is 1/2, what's 3 times 1/2? Positive. Times 1/2 minus 1? Positive times negative is? Okay, but f prime is 2. 6 times 1 is definitely going to be positive. So guess what we're doing here? You have to show your work to show the following. Okay? Now, these are your 3 division marks. You have 3 division marks because of 2 critical numbers. You have negative infinity past your first one, and you have infinity past your second one. Okay? So you're going to say what on your answer for your homework tonight? You're going to say increasing from, you only care about x values, guys. X values. So that would just be negative infinity to, not -1, that's the number we picked, right? Would 0 be our division spot, right? That's our division spot right there. To 0. And then the u just means what? Union? And then where else is it positive? Where else is it increasing from? 1 to infinity. And then therefore it decreases from what open interval? From 0 to 1. Remember, when f prime equals 0, does that tell you if it's increasing or decreasing? No, it's just constant. So take a look at this answer, which is what you got to tell me today, and look at the question. All right? From negative infinity to 0, is it increasing? From 0 to 1, is it decreasing? And then from 1 up, is it going to be always increasing? Now, I'll give it to you now because you need to see it, okay? Where is your maximum and where is your minimum? Is it pretty obvious when you realize this on the picture, okay? But what I want you guys to think about is it obvious on the sign chart as well? Yes, because what's happening everywhere from negative infinity to 0? It's always going what?
Positive.
And then what happens after 0? It starts going
Constant.
which means you're going up, you're going down, that's a relative maximum. Now, you're going down, you're going down, you're going down, you're going down, and then you hit 1, and then you start going up. That means it's going to be a relative minimum. So there's some examples of things to look at, the brown box on page 180. Okay, the first derivative test is exactly what we're talking about here, okay? Sign charts galore. Show me your work. Your work is a sign chart. So here we go. Here's what they're going to say, and please get this down. If f prime changes from negative to positive, then it is a relative maximum. Again, from negative going down to positive going up, does that mean you're going to have a minimum? Let me just go down a touch more. So, from f prime, negative to positive, this is called a relative minimum. If f prime changes from positive to negative, so here we go, blue line positive, blue slope negative, this spot right here is going to be a relative maximum. That is how you need to be ready to answer these questions. Okay, half of x minus sine of x. Here we go, lovely. Y equals half of x minus sine of x. 6. Do you have a region from 2 to 7? No. No, within good taste, 0 to 2 pi, we do. Am I doing absolute extrema? No, we're doing relative extrema. So here we go. What is the derivative? Derivative is what? Half. What's the derivative of this one? Now your job is to find what this equals. 0. So your trig skills, pretty please. Cos of x equals 1/2. Usually 2 times. What is cosine positive? 1/1 and 1/4. So cosine is adjacent over hypotenuse, which means this angle is 60 degrees. In radians, that's what? Pi over, okay, pi over 3. And then 300. That will be what, guys? 5 pi over 3. And you guys need to be good with that. You guys absolutely need to. So then we have 2 critical numbers. So now we're going to bust out the sign chart. It's painful, I know, but it's good math and very satisfying if you get it right. So from -infinity to, which is the first one? Pi over 3. From pi over 3 to 5 pi over 3. From 5 pi over 3 to infinity. You need to find values in between those, okay? Because if you plug in this and this, you get 0, don't you? Doesn't help us if it's positive or negative. So now think of trig numbers, guys. What trig number is a good one between -infinity to pi over 3? 0, yay! Okay, you can say pi over 2 if you want. 0 sounds good to me. From 60 to 300. Now remember, we're going to do cosine numbers, right? Just remember that. Okay? Are you guys saying pi?
Yeah.
Sure, why not? And then, what's a good number between 5 pi and 3? This one?
2 pi.
Yeah, we don't want to use 2 pi because remember, oh yeah, we can't use 0 then either. Because we're going from 0 to 2 pi, okay? I know, you guys like this so hard. Pi over 4. Is that 45 degrees? That's an easy one to do, right? Okay, over here then. In the spirit of 315 degrees, I mean, after all, if you're doing 45 on one of them, would it make sense to do 45 on another? Okay. You have to? No. Use 7 pi over 3, I don't care. Remember, this might be non-calculated. Okay. Guys, we did a lot of fooling around. Let's get going here. Is this f prime? So what's 1/2 minus cosine of pi over 4? What is cosine of pi over 4? Stink. What is that number? Is that 0.707?
Right.
So what's 1/2 minus that? Is it positive or negative? Good. That was easy. Okay, so that's a minus sign there. What's half minus cosine of pi? What is cosine of pi? So what's 1/2 minus -1? 7 pi over 4. So what's 1 minus cosine of 315? Again, cosine of 315 should be a positive number, right? So what's 1 minus what's 1/2? Why did I put a 1 here? Should be 1/2, right? 1/2 minus root 2 over 2 should be a minus sign. That's it. Now you can talk about your intervals and your relativity. So you would say what here? You would say, I don't care which one you start with, decreasing from infinity to open intervals, guys, comma, or I don't care which one you use. 5 pi over 3 to infinity? And then increasing from 5 to 3. Okay? Now, look at the board, look at the sign charts. Minus plus minus. If that's true, then this spot right here, relative max or min. Guys, it's going from decreasing to increasing. Therefore, you should also know how to write this down as well, guys. Make sure you guys know pi over 3 is a relative mini. And then if f prime changes from positive to negative, That means this number here, max and Ruby. 5 pi over 3 is going to be a relative Ruby. No. Okay? So, is your knowledge of derivatives going to have to pay off here? Solving equals 0, going to have to happen. Plugging it into the function? No. Plugging it into the derivative. Okay? So, what I want to try to do is, yeah, let's look at examples 3 and 4. I'm content to let you guys have it now, but I want you guys to take a look at a few questions I don't have for you, okay? All right, what's happening here? This is a wacky picture. I don't want you guys to see the picture until you see the wacky derivative. Guys, quotient rule, excuse me, chain rule, product rule, is that true? Or power rule. 2/3 times, don't forget the power, the chain rule. Guys, what are your critical numbers here? Is it just gonna be the 2 here? No, remember, critical numbers can also equal undefined. So would we have 0 be the undefined one? And would 2, plus or minus 2, work here? And so what happens now, we have a ton of sign charts, don't we? From -infinity to -2, -2 to 0, 0 to 2, 2 to infinity. Again, are you plugging in a test value and you're putting that into the function? No, you're putting it into the, so this is negative, decreasing, positive, increasing, okay? Take a look at the picture. Have you ever had problems with differentiability? Continuity. Is this function continuous everywhere? Is it differentiable everywhere? No. So take a look and see the jumps that happen, okay? Guys, the y-coordinate is not a big deal. You guys hear what I just said? The y-coordinate is not a big deal. What is a big deal is your x numbers and what they are, okay? Is this a relative max? Relatively speaking, there you go, okay? How about this picture? Again, exotic graph. Long, divide, yeah. But even when you do that, watch what happens. When you do the derivative, when does this thing equal 0 or undefined? Look what they did. Did they make it simplest form? So guys, it'll be either at plus or minus 1, or no, 0, right? And plus or minus 1, yeah. So again, do we have a lot of sign charts there? And again, we have decreasing, increase, decreasing, increasing. Look at this one. Why is that true? Because is the function not even continuous at 0? So you get some weird looking things, okay? Can I give you one that's not in the book? It is in the book, but I'm not going to tell you where, okay? How about this one, guys? Y equals x to the 4. Intervals of increasing or decreasing? Better yet, max and mins. Oh, that's x to the 4th? Okay. X cubed. There we go. Let's do one like this. You guys should know this one too, shouldn't you?
Yes. Increasing.
Where?
Everywhere.
Can we prove it using a sign chart? This is really quick. What's the derivative?
0.
Equals 0 when?
0.
Okay, here we go. So, simple sign chart. Please tell me 1, -1 in the right spots. What's f prime of -1? What's 3 times -1 squared?
3.
What's 3 times 1 squared?
3.
So is this thing increasing for all of the numbers?
Yes.
From here to here. Where's their max or min?
Not exist.
Where's a relative? There's none, because it kind of goes like this, and oops, you guys know it's just going to be. And that's not a max or a min, but is this derivative equal to 0?
Yes.
Yes, okay? So watch out, be ready for that there, okay? Yeah, I feel like I'm going too fast, but you know what? I'll give you the time here to start your homework. I do need to see your sign charts, which means you don't have 50 questions to do, all right? But you do have a good set. I'll even tell you what tomorrow's is too. So I'll give you guys today's and tomorrow's work, if you guys want to get